To be able to sort objects, it's necessary to be able to compare them. Now, the comparison results in a negative number to indicate less than, a positive number to indicate greater than, and 0 if they're equal. In the example in the previous lesson, the string object did that by comparing the ASCII characters. We are going to store objects of this class in a sorted collection. It's just a simple wrapper for a string name and a number. We're going to sort it first by one, then by the other. You can build one comparison method into the object and use it for sorting. Objects of the name tag class can compare themselves to others so they have a natural order. To do this inside a collection, it is necessary to implement the comparable interface. When they are placed in a sorted collection, the objects are cast to comparable objects and compared. This is the method that's called to do the comparison. This example just compares the name strings and ignores the numbers. Here is the construction of a tree set object that will be a container for name tag objects. It will hold them in a sorted order according to the compare to method that we just looked at. Inside the collection, the name tag objects are cast to comparable objects, and the compare to method is called to put them in order. The tree set has 5 name tags added to it in no particular order. Then an iteration loop is called to read them back and display them in whatever order they are being held internally. Here's how it runs. You can see that they were sorted according to their names. If you want to vary the order, you could change the compare to method to sort them in any order you'd like. But there is another approach you can take. You can write an external comparator and use it instead of the internal comparison method. This class is used solely to make comparisons. It implements the comparator interface to be a comparator objects for name tag objects. It only has the one method. The compare method performs a comparison between 2 name tag objects. It does so by subtracting the numbers. The result is negative, positive, or 0, just what a collection needs to be able to put things in order. Using this new comparator on the constructor causes the tree set to use only the supplied comparator to put things in order. The rest of this example is just like the previous one. And here's how it runs. You can see that the names were completely ignored this time. The name tag objects came out of the collection in numeric order. In the next lesson, we're going to do a little more than just iterate in order. We're going to read by the key.